In a September 2016 issue of Time magazine, Dr. Mark Tarnopolsky said that if there were a drug that could do for human health everything that exercise can, it would likely be the most valuable pharmaceutical ever developed. To understand what makes exercise so great, we need to understand how it affects the brain. First off, what is the brain for? Some may say we have brains to think, to create art, and to come up with creative solutions to complex problems. But neuroscientist Daniel Wolpert argues that this is not the case.
We have a brain for one reason and one reason only, and that's to produce adaptable and complex movements. There is no other reason to have a brain.
To illustrate this, Daniel uses the example of a sea squirt. Early in its life, the sea squirt has a nervous system. It will use this nervous system to move around and find a suitable rock to attach itself to. Then it will spend the rest of its life there. At that point, movement is no longer a necessity for survival. So the very first thing that the sea squirt does is it digests its brain for energy. A more relatable example is the koala. The koala has adapted its digestive system to derive all the energy it needs from eucalyptus leaves. It really doesn't need to move around that much, as it can just sit in a eucalyptus tree, eat, and watch the world go by. Earlier in the koala's evolution, though, it used to have a much bigger brain. However, once its diet became less diverse and required less movement to survive, its brain shrunk. Less movement meant less brain was necessary. What research on exercise is suggesting, and a better understanding of neurochemical mechanisms is proving, is that there is a very powerful connection between the brain and movement. A big brain is necessary to facilitate complex movements, and executing such movements and getting your heart rate up bolsters your brain power. Exercise has been shown to help people learn much more efficiently, better deal with stress, and drastically reduce anxiety. It improves mood to the point of lifting people out of depression, and it strengthens focus to the point that some ADHD patients elect to throw out their prescriptions. And that's not even the full list. The California Department of Education has consistently shown that students with higher fitness scores have higher test scores. A 2007 study showed that subjects who did high-intensity exercise beforehand could learn vocabulary words 20% faster than those who remained sedentary. The key to this phenomenon is a protein called brain-derived neurotrophic factor, or BDNF for short. BDNF is a crucial biological link between thought, emotions, and movement. A 2013 study in the Journal of Sports Science and Medicine showed that just 20 to 40 minutes of aerobic exercise increased BDNF in the blood by 32%. Rather than stocking up on coffee before you sit down to study, you might want to try jogging around the block instead. In order to learn something, the brain actually needs to grow and modify its cellular infrastructure to allow neurons to fire more easily. One way to understand why exercise would trigger your brain to initiate learning mode like this is to think of your body as the world's most intricate if-then system. Your body has triggers for almost every physiological process. For example, if cold, then shiver. If hot, then sweat. Most of your body's physiological expressions can't be induced just by force of will. Certain triggers must be present. Alexa, increase my testosterone by 50%.
I'm sorry, Dave. I'm afraid I can't do that.
By understanding which physiological triggers influence which physiological expressions, we can start getting our brains to do what we want. The reason exercise is a key trigger for all kinds of positive effects in the brain, particularly learning, is because movement signals to the brain that something important is happening. Maybe not in modern times, but originally, when we were moving, it was for the sake of survival. You move to escape a predator, to forage for food, to hunt, etc. While moving, it's in your best interest to learn the lay of the land so you don't get lost and can locate forageable food again. You had better remember how an attacking animal moves and what path was most efficient to escape so you can prevent yourself from becoming a carcass next time. When you're loafing around, you're not convincing your brain that learning is necessary. From your brain's perspective, being sedentary means you're safe. Nothing important is happening, and it's time to rest. We owe our motivations and entire will to live to the brain's reward center. With almost any activity we choose to do, we do it because we expect some sort of reward. We strive for success in life because we expect the reward of fulfillment. We eat candy for the rewarding taste. And we do taxes for the reward of not getting audited by the IRS. Without reward, our brains don't have much reason to do anything. An anti-obesity drug called rimonabant was a tragic example of this. Rimonabant is an endocannabinoid antagonist. It's an anti-marijuana medicine, which also means it's an anti-munchies medicine. It gets you to stop eating by inhibiting the sense of reward from food, and unfortunately everything else. 20% of users experienced serious depression, and there were several suicides. Kill the reward system and you just might want to kill yourself. Dopamine is a key player in the reward system. Dopamine is all about motivation and attention, and is responsible for the feeling of satisfaction when we accomplish something. It makes you want to do things and reassures you that the thing was worth doing. So if your dopamine is not working properly, you can find it hard to get things done, because you're not getting enough fulfillment to justify doing them.